we're going to cover 5A, which is the Introduction to Volume. Our content objective is students will be able to find the volume of cylinders, cones, and spheres. Our language objective is students will be able to explain in words how to find the volume of cylinders, cones, and spheres. Why am I learning this? Well, it's important for real-world problems like determining how much wax it would take to fill a jar to make a candle. So in this case, we're thinking that our jar is the shape of a cylinder. So first we're going to go over some background knowledge. Here you see the shape of a circle. There's a few terms that I want to go over so that you're familiar with them again. So first is the diameter. The diameter is the entire length of a circle. There's another term. Then we have the radius, which is just half of the length of the circle. And radius is going to be something that you need to make sure you understand because we're going to use radius in our formula. Please do not confuse a radius for the diameter. Again, diameter is the full length. Radius is just half the length of a circle. And last but not least, another very important thing to know before we get moving with our lesson is how to find the area of a circle. The way we find the area of a circle is we multiply pi r squared, and r stands for radius. So again, notice you need to be able to identify which is the radius because it's going to be used in our formula. So let's try it out. Let's take a look at what a cylinder looks like and how to find the volume of it. So first of all, in order to find the volume of a cylinder, you're going to go ahead and take the area of the base. And so what we use is a capital B to represent that. So in your notes, I want you to write a capital B stands for the area of the base. So notice it's not a lowercase b, it's a capital B. So let's take a look. Our base for a cylinder is a circle, so we would take the area of a circle. But guess what? A cylinder is not just a circle, it has height. Today we're going to be using the word altitude. So instead of using height, we're going to use the word altitude. It's the same thing, but I want you to be comfortable with both terms. Since I know you know what height is, I'm going to be using the word altitude to get you familiar with it. So since it has height, not only am I taking the area of the base, I got to multiply it by the altitude. And that's what's going to give me volume. And volume, just a friendly reminder, is how much space an object or substance occupies. So on that note, let's go ahead and jump into an example. Here, for number 1, it says, find the volume of the cylinder in terms of pi. So here, we're going to be asked to leave our answer in terms of pi. We won't multiply it out to a decimal, so it's actually going to save us some time. So first things first, what I'm going to do is go ahead and write down the formula. I highly suggest you write down the formula every single time to help you remember. It's kind of like rewriting your spelling words over and over so you get practice and you remember it eventually. So here I'm going to write the volume of a cylinder is the area of the base times the altitude. So here, what is our base? Our base is a circle, which is why I went ahead and wrote down pi r squared, because that's how you find the area of a circle. But not only do you have to do that, you're going to have to also multiply it by the altitude. So now that I have that, I'm just going to collect some data. For here, I'm going to need to figure out what the radius is. So what they gave me here is my radius because it's half the length of the circle. So I'm going to go ahead and put pi r squared. Since the radius is 3, I squared it. But now I need to multiply by the altitude, and the altitude is 8. So I'm going to go ahead and write times 8. Now what I will do is go ahead and expand this. I'm going to write it as an expanded product and write down pi times 3 times 3 times 8. Once I've done this, I'm going to go ahead and multiply all the coefficients together. 3 times 3 is 9 times 8 is 72. So I'm going to write 72 pi centimeters cubed. So first of all, I want you to pay attention. I did not write pi 72. In math, pi will always follow the number. If you ever have difficulty remembering does pi go in the front or in the back, think pi, P-I-E, the dessert, When do you normally have pie? When do you have dessert? Do you have it in the beginning of your meal or at the end? Normally you have it at the end. So if that helps you remember to put pi after the number, definitely use that strategy. If not, don't use it, but just try to remember pi goes after your term. Another thing I want you to focus on is that my units is cubed, okay? And the reason why it's cubed is because volume measures the space, and space is a three-dimensional measurement, and that's why it's cubed. Or another way you could think of it is this was 3 centimeters, this was 3 centimeters, and this was 8 centimeters. So how many times did centimeters appear? 3 times, and that's why we would cube centimeters, okay? So, let's clear everything, continue on. So here I would say the volume of the cylinder is 72 pi centimeters cubed. Okay, so now let's take a look at another example. Again, we're going to find the volume of the cylinder in terms of pi. So first things first, let's write down our formula. The volume of a cylinder is capital B, which is the area of the base times the altitude. And again, what is the base? The base is a circle, so I'm going to go ahead and put pi r squared, and I still need to multiply it by altitude. Now, for this part right here, I need to figure out what the radius is. So let's take a look. Well, they gave us an entire length of the circle. That's actually the diameter. So if my diameter is 8, my radius would only be half of that. So I would say the radius is 4. So let's plug that in. We have pi 4 squared. Now we need to multiply by the altitude. Well, I know this looks a little bit deceiving, but the altitude is not 8. The altitude is actually 2. This is the length of the cylinder. So I would write times 2. So let me just draw a quick figure of what this would look like if it was upright. It would look like this. Okay, my ugly cylinder, I apologize. So here it's 8 and here it's 2. So technically my height is 2. So be very careful. So notice this cylinder, it's kind of like tipped over on its side, but 2 is still going to remain the height of the actual cylinder. So you have to be very careful. So let's move on. I'm going to go ahead and write 4 squared as an expanded product. So that's pi times 4 times 4 times 2. Now I'm just going to go ahead and multiply what I have. 4 times 4 is 16, times 2 is 32. And again, I would write 32 pi. Pi follows the number. It goes at the end. And I would write centimeters cubed. So I'm going to say the volume of the cylinder is 32 pi centimeters cubed. Now, let's take a look at a cone. Before we go ahead and talk about the volume, the formula for the volume of a cone, let's take a look at this quick video.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is 1/3 of the volume of the cylinder.
So now here we have a triangular pyramid. This is actually very similar to a cone. Why? Because it has a base and it has a point, which we call an apex. So here, the formula is actually identical to that of a cone. It's going to be the area of a base times the altitude divided by 3. Now the only difference here is my base is not a circle. According to this pyramid, the base is a triangle. So what I'm going to do is I'm not going to put pi r squared because it's not a circle. I'm going to find the area of a triangle, which is base times height divided by 2. Now I'm still going to multiply by the altitude, and I'm still going to divide by 3. So first, let's go ahead and take a look. We have a triangle. Let's find the area of that triangle. And again, we just do base times height divided by 2. So I'm going to say base is 5, height is 2, and then I have to divide by 2. Now let's take a look at the altitude. So what is the altitude? The altitude is 6. So I'm going to go ahead and multiply that by 6. And then last but not least, I have to divide by 3. Now, I know this looks pretty ugly, but we can go ahead and simplify, and not simplify, we can cross cancel and see what we can do to make these numbers a little bit more cleaner. So here, I notice I can cross cancel out the 2's. I'm going to divide both of them by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. I also notice between the 6 and the 3, I can cross cancel and divide both of them by 3. So 6 divided by 3 is 2. 3 divided by 3 is 1. So I know it looks very messy, but just go ahead and multiply straight across. 5 times 1 is 5. 5 divided by 1 is still 5. So I'm going to do 5 times 2 is 10. And 10 divided by 1 is still 10. So I'm going to say that the volume of the triangular pyramid is 10 centimeters cubed. Okay? So notice this answer does not have pi. So please don't go pi crazy and just put pi everywhere you see a volume problem. Okay? So be careful. Okay, so now we have a rectangular pyramid. How do we find the volume of a rectangular pyramid? Well, it's the same as the cones and the other triangular pyramid. You're going to go ahead and take the area of the base, multiply by the altitude, and then you're going to divide it by 3. But now, we got to take a close look. What is our base? Our base is a rectangle. So here, I'm going to go ahead and change capital B to a base times height, because that's how you find the area of a rectangle. I still need to multiply by the altitude, and I still need to divide by 3. Now, let's go ahead and take a look at our rectangle. It's 4 by 3. So again, how do I find the area? It's just base times height. So I'm going to go ahead and do 4 times 3. Then let's take a look at our altitude. Our altitude is 15. So I'm going to go ahead and multiply by 15. And last but not least, I have to divide by 3. Now here we have some options. Some students are going to see that they can cross cancel the 3's and say 3 divided by 3 is 1. 3 divided by 3 is 1. So 4 times 15 is 60 meters cubed. However, other students may see that they can cross cancel with the 15 and the 3. And they'll say, okay, I can go ahead and reduce it by 3. 15 divided by 3 is 5. 3 divided by 3 is 1. If you multiply, here you have 4 times 3 is 12. 12 times 5 is also 60 meters. Okay, and last but not least, the other option would be to do 4 times 3 times 15 and then divide by 3. But that's going to be a little bit more work, so I highly do not suggest that method. Always cross cancel when you can, because you want to reduce those numbers down. So my answer is going to be the volume of the rectangular pyramid is 60 meters cubed. Okay? So last but not least, let's talk about the spheres. How do you find the volume of a sphere? Well, here is your special formula. You need to make sure you write down and you remember forever and ever. The volume of a sphere is 4 pi r cubed divided by 3. So it says here, find the volume of a sphere with a radius of 3 units in terms of pi. So again, I'm going to be asked to leave it in terms of pi. So all you really need to do is identify what the radius is. And so here, it is half the length of the circle. So I'm going to say the radius is 3. So I'm going to plug that in. 4 pi 3 cubed divided by 3. I'm going to go ahead and write 3 cubes as an expanded product. And then I'm going to go ahead and check to see if I can cross cancel. I can. I can go ahead and divide the numerator and denominator by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. So you're probably wondering why I'm choosing to expand the 3's. In the very last problem, you're going to have a better sense of why I'm doing that. So just for right now, just believe in me and trust me. So
I'm going to go ahead and multiply straight across. 3 times 3 is 9, times 1 is still 9, times 4 is 36. 36 pi divided by 1 is 36 pi. So notice when I multiply, I don't necessarily go in order. I kind of jump around. What allows me to do that is a commutative property. So please don't feel like you have to go in order. Do what's easiest for you. Okay, so I'm going to say here, the volume of the sphere is 36 unit cubes. And again, please don't forget to write your units, and please don't forget to write cubes when you're trying to find the volume of a shape. Okay, so now let's look at one last example. First, let's write down the formula once more. The volume of a sphere is 4 pi r cubed divided by 3. So it says here, find the volume of a sphere with a diameter of 12 units in terms of pi. So first things first, I need to figure out what my radius is. That's the only thing you need to figure out for the volume of a sphere. Well, they gave me the entire length of the sphere, which is 12. I don't need the entire length. I just need half of it. So I'm going to say the radius would then be 6. So let's plug that into our formula. 4 pi 6 cubed divided by 3. Now let's go ahead and write this as an expanded product. So it's 4 pi times 6 times 6 times 6 divided by 3. Here is why I make you expand it. Because of this, you're able to cross cancel. Okay, 6 divided by 3 is 2, 3 divided by 3 is 1. If you went ahead and just multiplied it out, it's going to create just a little bit more work because you have that possibility that you're going to have to multiply large numbers multiple times, okay, which is not going to be favorable. So now I'm going to go ahead and multiply straight across. I'm going to say 2 times 6 is 12. 6 times 4 is 24. 24 times 12 is 288. So again, notice, I don't go in order. You don't have to go in order. Okay? So it's 288 pi units cubed. So please, again, remember to write the units, remember to write cubed, and most importantly, don't forget your pi. Never forget your pi. So I'm going to say the volume of the sphere is 288 pi units cubed. And that concludes our lesson. Thank you for tuning in. Bye.